million-dollar question is how. Generative AI is saying, I just fed you a data set. All this relationships are between my inputs, my outputs, and the physics. All models are wrong, some are useful. And that's because models are simplified versus the real world. I could reduce millions of degrees of freedom down into a pretty simple relationship. My in is this and my out is that. If you're not paying attention, then you're automatically going to have an outdated view of what the capability of these tools are, of what the cost of them are. If generative AI and simulation AI tools are more accessible, you're going to use them more often. Designs are just going to be better.
All right, question number 1. What role does AI play in engineering simulation today?
Yeah, that's a great question, Yusuf. I mean, it's a loaded question. I mean, we've had AI in engineering, and if I take a step back for a second, you know, what does that mean? What do we mean AI in engineering? For me, that just means, do we have a predictive model, right? And so how we predict the future as engineers, how we predict what a new design, you know, might do, how it might perform, there's various technologies, right? So AI is just the latest sort of algorithm sets, data sets, and approach for predicting the future for, you know, for any design. And so, you know, we've had the ability to take a bunch of information, test data, simulation data, put it together, interpolate some solution, and say, hey, this is an optimized solution. So today, what I see in AI is, hey, I've got this historical data, right? I've got this, you know, generational sort of prior designs and how well they've done, reliability, performance, et cetera. And I want to come up with the latest design, new materials, new, you know, manufacturing processes, whatever. How is it going to perform? I mean, that's like the engineer's dream. That's what we're trying to do here. And so, you know, the latest AI tools facilitate that. The million-dollar question is how, right? How do they do that? That's a little bit longer answer.
Question number 2. Why is AI becoming so critical in simulation workflows, and how is Ansys integrating it into its tools? Can you give us an overview of the key AI-powered solutions in the Ansys portfolio?
Yeah, so a couple things to unpack. The first question was how is AI being used? And today, the way that we're seeing it and the way that we're using it, our customers using it, first and foremost is in GPTs, right? So we have customers up until last year, I would say, if you had a question about FEA, CFD, right? You want to know, right? Asking students, asking young engineers, hey, if you want to know right there in the middle of your workday, you need to learn something, what are you going to do? And if you asked anyone up until, say, 2023, maybe even through last year, they would have said, I'm going to Google. I'm going to Google. I'm going to type it in you know, and hit enter, and I'm going to see what happens. And what happens now is it sends you out to the internet, and you're getting a bunch of noise. I don't want to say junk, because there's some good information out there, but you got to sift through the junk, right, to get the good stuff. Well, if you ask an engineer now, you ask a student in college right now, you ask them, hey, if you're trying to learn Ansys, or you're trying to learn FEA, CFD, simulation techniques, and you have a question, what do you do? And there's going to be a split now between Google and ChatGPT. And future engineers, they don't care. They're going to just go to whatever search bar is closest to their mouse button, right? And we're starting to see these search bars get embedded in the tools. So right now, you know, we've got Ansys GPT. Ansys GPT is a large language model. It's at your fingertips. You just open it up and you type in, hey, I'm trying to do this thing in Ansys Mechanical. And it will automatically search all of the databases that we have. So that's the first implementation of AI, right? Are these large language models, I'm typing in text and I'm getting answers. It's like having your own personal assistant, except for Ansys GPT, you have a personal assistant that is completely trained in Mechanical, Fluent, and the entire portfolio. And they're instantly tapped into our learning material, our tech support material, the help files, everything instantly. And so that's a huge value, right? Because if you're stuck and you're learning, the last thing you want to do is wait, and the very last thing you want to do is find a bad answer and have you go down a route that's wrong, which we see with the junk that's out there on the internet, you know, right now. But that's just the starting point. The starting point is, how do I aggregate all this technical data and get it easy to find at my fingertips? Really what we want to do is we want to embed AI into our simulation math, okay? Not just a tech support tool, but in the simulation math. And so what we have in our portfolio right now is we have an AI implementation that's centered around big data. So what do I mean by that? Instead of doing one simulation, I do 10 or 100 or 1,000. And so we have a lot of statistical math that we wrap around our physics. And there are ways to optimize within that data set. And so we've got some AI algorithms that allow us to do that. That is what I would call sort of interpolating AI, right? Let's talk about extrapolating or generative AI. Generative AI is saying, I just fed you a data set. Now you know what all these relationships are between my inputs, my outputs, and the physics. Now I want to give you brand new geometry. I'm going to give you I'm going to give you a what if scenario that you haven't seen. It is outside or extrapolated from the training data. And that's our Sim AI tool. So, however you want to use AI in simulation right now, there's a couple different options. I think the jewel in the crown, if you will, would be the QnA tool, which is basically saying I've got a predictive generative AI tool that I'm running on the fly, and not only is that fed with high quality training data, say historical, but I'm actually feeding it live on the fly with sensor data from a machine or from the field. It doesn't get any more accurate than that.
Number 3. Ansys Sim AI claims to deliver results in seconds instead of hours. How does it achieve such drastic speed improvements?
Yeah, everybody wants to know. First off, the relationship between speed and accuracy has always been, a little, a little bit of a battle, right? That engineers don't trust an answer if it comes too fast, right? Because we kind of know the real world is nonlinear. The real world is full of noise, and it's sometimes really hard, right? All models are wrong, some are useful, and that's because models are simplified versus the real world. And if you take a model and you simplify it so much that it becomes seconds to solve, engineers don't want to trust it. So how do we do that? Well, of course, as we mentioned, training data, and you want to feed it, say, dozens or even hundreds of prior sets of data. That can be a simulation, a trustworthy, full physics simulation, and that can be some test data, right? But what we do with that, and I'll give you an example of CFD, right? So I plug in, my geometry. I have, a couple million cells, and a couple million cells inside of that takes hours to converge, okay? So I've now waited and plugged in all this information, but I've got a reliable answer, and I know it's going to match test data. Takes me, hours, right? Reality is once you've converged that, and you've got a full field of temperatures, pressures, velocities, densities, whatever, the reality is if I did a sensitivity study on the inputs and understood how much they impacted the outputs, I could actually take this full field, millions of cells, and break it down to a very, very simple equation. I could reduce millions of degrees of freedom down into a pretty simple relationship. My in is this, and my out is that. And that's what we call a reduced order model. So I'm reducing the order of the problem. The order started off as millions of degrees of freedom. Now I'm reducing it to 5, right? If that reduced order model is accurate, I can now predict the answer of millions of cells and thousands of iterations of CFD in a matter of seconds. Because I have a trustworthy relationship, a mathematical relationship between my inputs and my outputs. That's how it's working. That's how it's so fast. The $1 million question, of course, is if the reduced order model is representative of the full physics. And again, that's with training it with a broad range, deep set of training data.
Excellent. Good stuff, Jim. Question number 4. One major challenge with AI models is getting reliable training data. How does Ansys tackle this issue?
Yeah, that's the $1 million question. I think that a great source of training data, and there are several, a great source of training data are full physics simulations, right? So we've got customers who say, hey, I don't have historical data. I got a design out in the field. The engineers have all retired, okay? The new engineers have no idea how it works. The test data is written in pen and paper and locked in a cabinet somewhere, or it accidentally got thrown out. So how do I build up training data on historical designs? I know that they're in the field. I know they're reliable, but that's not enough. A reliable design is not enough to feed into a sim model. So reverse engineer that, put it in a full physics model, FEA, structural dynamics, CFD, heat transfer, whatever, and solve it. And get that model to match your test data. Do it again. Do it again. New temperatures, new flows, new forces, new displacements, new temperature profiles. Just start creating data sets, millions and millions of data points with spatial discretization, right? So 3D CAD files, all the data, temporal, right? So transients, right? And that data, when it matches existing test data, you can fill up gigs and gigs and gigs of hard drives and use that to train. The test data, on the other hand, is not full field, right? I don't, when I make a heat exchanger, I don't know the full temperature field of that heat exchanger. I don't have enough thermocouples. I can't afford enough thermocouples. I've got maybe half a dozen thermocouples. I've got maybe an IR camera, and I'm using, all of their own, sort of error, but I'm feeding that in. So you really have to get, I think, a mix of training data, but the quantity side of the training data, that's going to come from simulation, no doubt.
Question number 5. How do you see AI evolving in engineering simulation over the next decade?
So the next 10 years in simulation is really all about AI. And what I mean by that is creating predictive models that are more intelligent, that may require less training data, or we start building out as a society, as an engineering population, we start building out public training data sets, right? Now, companies don't want to share their training data because that is intellectual property. It was very expensive to build. They don't want to just give that away. But I think at the industry level, if you think about some of the industry, organizations, right? So ASME, ASTM, SAE, right? So mechanical engineering, aerospace, maybe civil, architectural, like those industries have a vested interest to regulate and control the quality of engineering. And so I see over the next 10 years, there being initiatives for maybe those organizations or others to populate publicly available or privately behind a paywall for the capitalists out there, right, who want to do this on their own. But the reality is available training data. So the next 10 years, we're going to have available training data that you can either purchase or just download for free. And that's going to increase the quality of simulation, generative AI tools, and engineering. The other side of the coin, of course, on the speed side, is hardware, right? The democratization of computing power, right? And of course, primarily we're talking about CUDA cores on NVIDIA GPUs and the whole technology, right? So like we're breaking, Moore's law has been dead for a while, right? But we've got other technologies that are facilitating insanely fast computing. So I've got loads of training data, so the quality is going up and the quantity is going up. So and the speed of generative AI is going to keep going up. And so all that does is make it more accessible. And if generative AI and simulation AI tools are more accessible, you're going to use them more often. And now these optimizations are going to be even better. We're going to be factoring in, all the different variables. Designs are just going to be better.
Sweet.
Yeah, great question.
Are there any misconceptions about AI and simulation that you'd like to debunk?
Misconceptions. I mean, the misconceptions around, generative AI for engineering and simulation are the same misconceptions that we've had in simulation for the last, generation or two. And that is the belief of what the cost or the difficulty is, right? And again, these tools are changing about every 6 months, right? Simulation tools are changing every 6 months. AI capabilities are changing at least, or I'd say at most every 6 months, possibly even, faster than that. If you're not paying attention, okay, then you're automatically going to have an outdated view of what the capability of these tools are, of what the cost of them are, and of what the complexity and the difficulty is, right? As we just continue to move forward, the cost is going to go down. And I'm talking total cost. I'm not talking about licensing costs, right? Software companies have invested interest to increase their licensing costs, presumably over time. But at the end of the day, the cost of using these tools, the total cost There's always a human labor, there's a hardware cost, there's training data cost. The aggregate total cost is going to continue to go down. The capability is going to continue to go up. And I think the misconceptions out there are just misalignments between you read a blog once a few months ago, or you got a piece of data from some podcast, self-serving here, some podcast that you believed, but you never corroborated it. I mean, at the end of the day, you got to stay at the cutting edge, talk to people, talk to a variety of people, get your news sources, get your technology sources from multiple areas. Don't just hone in on one particular source and do it often. Otherwise, you're going to have an outdated opinion.
Good stuff. And last but not least, finally, what advice would you give engineers hesitant to adopt AI in their workflow?
Advice for people who are hesitant to start to introduce AI. First off, is your hesitation is usually driven by a lack of understanding. So if you don't fully understand the tool, you should be hesitant. It was like the beginning of simulation, right? Like, I don't understand. Is that really what the stress really is? Well, yes, it is. The math has been proven, right? The tools are accurate. And that's beginning to be the case with AI, right? I think that, again, do your homework, get your research from multiple sources, not just, person who's got a vested interest in selling you something or somebody who, has old data. I think the other hesitation is people are fearful to introduce something because they don't feel like they have the bandwidth to learn, or that they're going to introduce a technical risk into their next project. So for those people, I would offer the following advice. Whenever you start a new project, push back on your management and your company to say, hey, listen, this project should include some bandwidth to try new tools. If you don't include, we're always adding in an extra week, an extra hour, an extra whatever in these projects because we don't know what risks lie ahead, right? That's the beauty of engineering. But you have to factor in, I think, specific effort into projects moving forward to add in the potential of new tools, right? A lot of times we see companies say, oh, I'm going to do a special project all by itself in a vacuum, and in that project, in that vacuum, I'm going to try a new tool because I want to compartmentalize the risk in my business. That's not a very accurate and realistic way to introduce AI, okay? Introduce AI into a program that can handle a small amount of technical risk. If the AI isn't working for you, fall back on the process that you know works, whether it's full physics simulation or hand calcs or, God forbid, trial and error testing, physical prototyping, right? So I think for those who are hesitant, it all starts with when you're initially scoping out projects moving forward, whether it's, CapEx, OpEx, whatever, talk to your project manager, talk to your leadership and say, hey, listen, we need to factor in an extra couple percent. And in that couple percent, I want to play around with new tools. And I think that's going to reduce the hesitation. It's going to reduce the risk, which is the most important part for these businesses.
Good stuff, Jim.